Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to embark a new topic of discussion which is on antenna design. Okay, so this video, I will be trying to cover all the different types of antenna. Okay, in fact, there are many more different types of antenna which I'm not able to cover in this video. Okay, however, in general, for this video, I'm going to discuss what is antenna based on wire antenna, log periodic antenna, aperture antenna, and last but not least, lens antenna. Okay, so this will be the part 1 series discussion on antenna. Okay, so please take a look on the playlist. Okay, so very soon, okay, I will upload the part 2 series discussion on antenna. On the part 2, I will continue the discussion on the different types of antenna. Okay, in fact, there are more than these types of antenna, okay, which will be covering on the part 2 series discussion. So guys, if you're keen to know more about antenna, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on antenna soon. Okay, so this is my email. If you have any question regards on this discussion, please drop me an email. Or if not, I strongly urge you guys to ask me the question through the comment. Okay, so this is because I hardly check this email. So guys, if you want to have a faster response, ask me through the comments. You can also suggest the topic that you guys are keen. Okay, so again, all this can be done through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe to this channel and turn on your notification bell. Once again, thank you so much for your strong support. Okay, so like I mentioned earlier on, okay, so this video, I try to cover as much as possible on all the different types of antenna. Okay, so this video, I will concentrate on wire antenna, log periodic antenna, aperture antenna, microstrip antenna, and also lens antenna. Okay, inside wire antenna, you probably can see that we have short dipole antenna and dipole antenna. Okay, so later on, I'm going to explain the key difference between these two, short dipole antenna and also dipole antenna. We also have loop antenna under wire antenna and also monopole antenna. Okay, as for log periodic antenna, okay, we have this bow tie antenna. Okay, how they get this name is because the antenna actually look like a bow tie. So hence it is actually called a bow tie antenna. I'm also going to explain what is the key difference between log periodic antenna and log periodic dipole array. Okay, so basically this will be discussed in this video. As for aperture, okay, which means that I have a so-called opening. Okay, so as the signal can be radiated out. Okay, so in short, under this aperture antenna, we have this slot antenna and also horn antenna. Okay, I have quite an extensive, okay, so-called familiar about microstrip antenna. Okay, we have this rectangular microstrip patch antenna. We also have this quarter wave patch antenna. And last but not least, on this video, I'm going to cover quickly on lens antenna. Let's quickly jumpstart on the discussion of the types of antenna. Okay, so on the part 2 series discussion, okay, I will concentrate on these 3 classification of antenna. But for now, this video, I'm going to concentrate on the first page, the types of antenna. Let's jump straight. What is actually a wire antenna? Okay, a wire antennas, they are in fact the most commonly used type of antenna. Okay, you probably know that any wire can be an antenna. So therefore, it is actually very common to find this wire antenna in vehicles, ship, aircraft, building, and of course, many possible other structure here. Okay, the wire antenna come in various shapes and size. Okay, for example, just a straight line, okay, as a dipole, we can also have this loop antenna and helix antenna. Okay, let's quickly understand what is actually a short dipole antenna. Okay, you can see that this is actually a short dipole antenna. Okay, so perhaps, okay, this is the simplest of all antenna, okay, which is the short dipole antenna. It is actually a special case of the dipole antenna. Okay, so basically, short dipole antenna is quite similar with this dipole antenna. Okay, so in its simplest form, okay, it is basically an open circuit. You can see that this is actually an open circuit on the two end here, okay, with the signal being fed at the center. So over here, we can see that the signal is being fed at the center, and you can see that on the two side, okay, which is open end. So basically, this is what is called a short dipole antenna. Okay, the term short in short dipole doesn't mean that it's actually very small or very short in terms of the size, but rather than that, it's actually compare the size of the antenna to the wavelength of the signal. So basically, the short dipole antenna is much smaller as compared to the dipole antenna, which I will illustrate on the next slide here. For a typical short dipole antenna, the length of the wire is less than a tenth of the wavelength, okay, which means that lambda divided by 10. Okay, so basically this will be the size of the antenna. As for dipole antenna, okay, you probably can see this diagram here. It's actually made up of two conductors in the same axis. Okay, so basically these are the two conductors, same axis. For example, this is x-axis, or we have this y-axis. So basically you can see that these two conductors, they actually are in the same axis. And typically they are half of wavelength of the operating frequency. Okay, so basically you can see that the size of these two axes, okay, basically is about half of wavelength, and therefore it is also known as half wave dipole. In short, short dipole antenna, as I mentioned earlier on, the length can be lambda over 10. Okay, therefore they actually get the name called short dipole antenna because it's much more shorter than the dipole antenna. Next, I'd like to move on to loop antenna. Okay, a loop antenna is a type of radio antenna. Consists of a loop. Okay, over here you can see that this is actually a loop or coil of wire. Okay, again from here you can see that this is actually a coil of antenna, tubing or other electrical conductor, usually fed by a balance source or feeding a balance load. Okay, so basically the antenna, okay, loop antenna, basically it will have a balance source, differential source, which means that, or it can actually feed to a differential load. Okay, so basically this is what it means here. The loop antenna are used in various applications, ranging from small signal turn loop antenna for portable device to large multiple turn loop for radio direction finding and communication. Okay, so in short, over here you can imagine that I can have some coil of wire, okay, so as to build up the volt per meter. Okay, so all this is all on loop antenna. Okay, last but not least, let's quickly move on to the monopole antenna, which is also part of wire antenna. Okay, a monopole antenna is a type of radio antenna that consists of a straight rope or conductor, usually mount over a ground plane. Okay, so over here you can see this diagram. Okay, like what I always say, a picture actually say a million words. So basically this is a dipole antenna, as I mentioned earlier on. Okay, so basically the length is so-called half wavelength. As for monopole here, you can see that this will be also a quarter wave, but on the other side is actually grounded to a ground. So basically this is what it means. A monopole antenna, okay, basically it will be like a dipole antenna. It will have a straight conductor, which is here, and typically it's actually mount over a ground plane. So basically on the other side is actually grounded on the ground plane. The monopole antenna is a variant of dipole antenna, okay, but it uses a single element. Okay, so it uses a single element with the ground plane acting as a reflective surface. Okay, effectively create a mirror image of the monopole element. Okay, so basically this is about the monopole antenna. Next, okay, let's quickly move on to log periodic antenna. Okay, so what are the benefits of this log periodic antenna? Is simply wide bandwidth. Okay, which means that this form of antenna, you actually can work in a larger bandwidth. So typically it is formed by different length, okay, driven elements. Okay, the longest and shorter elements are of half a wavelength long at the lowest and also at the highest frequency of interest. Okay, so under this log periodic antenna, we have this bow tie antenna. Okay, so this bow tie antenna, you can imagine that they are actually quite similar with the dipole antenna, but okay, instead of a wire, is actually has a antenna shape that look like a bow tie. So therefore, this is how it get its name, bow tie antenna. Okay, a bow tie antenna is a type of broadband antenna that get its name from its shape, which I mentioned earlier on. Okay, so basically is actually a variant, okay, basically of a dipole antenna. They look like a dipole antenna, except that it has a shape like a triangular or bow tie, okay, instead of straight wire. Okay, this design allowed the bow tie antenna to operate over a wider frequency, making it suitable for application require a broad bandwidth. In short, for dipole antenna, it has a narrow bandwidth, and in order to increase the bandwidth, you can consider to switch to bow tie antenna. Okay, so basically bow tie antenna typically has this triangular shape, and because of this, okay, the bandwidth actually increase. So therefore, it is much more suitable for application that require a broadband. Next, okay, what is the key difference between log periodic antenna and log periodic dipole array? Okay, so this log periodic antenna can refer to any antenna designed with a log periodic in the spacing or length of its element. Okay, so imagine this is basically a log periodic antenna. Okay, so this is a broom. You can see that all the element that is connected to the broom, okay, at an interval, okay, which is the log periodic spacing. Okay, so a log periodic antenna can have various configurations, including array of dipole, loop, or other radiating element. Okay, it can also have a single or multiple element along its length. Okay, so basically you can see that this is called a log periodic antenna. You can see that it actually has one broom and two broom, and you can see that it actually mounted an array of elements along its length, as illustrated over here. So therefore, this form here is called a log periodic antenna. Okay, so what is actually a log periodic dipole antenna? Okay, it's actually the same as log periodic antenna. Okay, so in this form, it actually is a log periodic dipole array. Okay, so basically this will be a broom. Okay, you can see that these are only just a so-called a planar surface of this element that is connected along the broom, okay, at the interval of a logarithm, as I illustrate on the log periodic antenna. Okay, so maybe in the next few video, okay, I will be able to concentrate on all these specific types of antenna. But as for now, okay, I just want to have a quick discussion, okay, on this log periodic antenna. Next, I'm going to move on aperture antenna. Okay, an aperture antenna is a type of antenna that radiate or receive electromagnetic wave through an opening. Okay, so basically we have some opening, as you can see from here. Okay, or aperture, okay, which is also called a hole in a conducting surface. So basically you can see that this is a form of waveguide. We basically have some opening or some slot, okay, that allow electromagnetic wave to either exit from the waveguide or enter into the waveguide. Okay, so as illustrated over here, the aperture serves as a radiating or receiving element of the antenna. Okay, so these antennas are commonly used in radar, communication system, and satellite communication. Okay, so under this aperture antenna, we have this slot antenna and also horn antenna. Okay, so a slot antenna is a type of antenna that consists of narrow slot or opening cut into a conducting surface, such as a metal plate or waveguide. Okay, as I illustrate, this is basically a waveguide. Okay, we are going to have some form of opening, okay, some form of design of opening, so as to ensure that electromagnetic wave can either enter or exit this waveguide. Okay, the slot act as the radiating element of the antenna, okay, allow the electromagnetic wave to propagate through it. Slot antenna are commonly used in RF, okay, which means higher frequency application, okay, due to the simple design and the versatile. Okay, so it's actually quite flexible. Okay, so this is actually on slot antenna. Let's move on to horn antenna. Okay, a horn antenna is a type of antenna that consists of a flare metal waveguide structure typically shaped like a horn, as you can see from here. Okay, so typically it looks like a horn, and therefore this is called a horn antenna. Okay, it is widely used in microwave. Again, it's on higher frequency application, okay, due to its ability to effectively radiate or receive electromagnetic wave over a wide frequency range with high gain and directional. Okay, so basically for this horn antenna is actually very directive, okay, which means that I can actually direct my signal to a specific direction. And also, it key idea is to have a high gain. Okay, so for high gain antenna, okay, we actually prefer to use a horn antenna. Next, okay, let's move on to this microstrip antenna. Okay, microstrip antenna is also known as patch antenna. Okay, they basically operate on the principle of microstrip transmission line. Okay, so basically this is a microstrip line. Okay, you can see that this is actually a patch antenna. So basically it's a conductive so-called element, okay, over a ground plane over here on the other side here. Okay, so basically this is a design of a patch antenna. Okay, they are widely used in various wireless communication systems due to their compact size, low profile, and ease of integration with PCB. Okay, so basically it can be so-called, the cost of this can be very low, okay, because I can actually make a patch antenna just like a PCB. Microstrip antenna consists of a metallic patch or patches print on one side of a dielectric substrate with a ground plane on the other side. Okay, so basically this is what I mentioned earlier on. Okay, for example, on over here, okay, which is on the front side, let's say. Okay, so basically this is all the design of the patch antenna. On the other side of this dielectric is basically the ground plane. Okay, so on this microstrip antenna, I actually have this rectangular microstrip patch antenna. Okay, you can see over here. Okay, so basically this is like a form of rectangular shape. Okay, so basically since it has a patch antenna design, on the other side is a ground, so therefore it's a microstrip patch antenna. Okay, a rectangular patch antenna with a dimension L approximate equals to half a wavelength must actually be less than. Okay, so in short over here, this length is actually need to be lesser than half of wavelength, okay, because of the fringing effect of radiation from the two opposite patch edge here, okay, which are L apart, and the ground plane. Okay, as long as the feeder line is on the center, okay, these two other edge do not radiate. Okay, so basically this is the characteristics of rectangular microstrip patch antenna. Okay, as for this quarter wave rectangular patch antenna, they are actually very similar, okay, with this rectangular microstrip patch antenna. Okay, remember earlier on I mentioned that this length is typically about half of wavelength. But for this quarter wave, okay, this L can be a quarter wavelength. So which means that they are actually smaller size as compared to the half wavelength rectangular patch antenna. Okay, so basically this is the key difference, okay, between this is actually quarter wave is actually a smaller patch antenna as compared to this rectangular microstrip patch antenna. Okay, let me quickly cover the last antenna on this video. Okay, so a lens antenna uses the converge and diversion property of a lens to transmit and receive signal. Okay, for example, this is basically for transmit. You can see that they basically from a single source they open up, and for receiving is basically they collect all the incoming ray and then basically they all focus at a particular point. So basically this is the meaning of converge and diverge property of a lens to transmit and receive signal. Okay, so this antenna consists of a dipole or horn antenna. Okay, imagine there will be a horn antenna over here, then followed by a lens. So basically followed by a lens. The size of the lens used depend on the operating frequency. Okay, the higher the frequency, the smaller the length. Okay, so basically, if I use a high frequency, then the length will become smaller. Okay, due to this lens antenna, okay, typically they are used at higher frequency as they can be quite bulky at low frequency. So in short, at low frequency, the lens can be quite big. And because of this, so therefore, this lens antenna probably will be used at the higher frequency. Okay, so like I mentioned earlier on the part 2 series discussion, I will still continue to discuss on the different types of antenna. Okay, before I end, okay, I seek your help to like, this video. When more of you guys actually like this video will have a better chance to reach up to a larger audience. So guys, help me by like this video now. If you learn something from this video, again, please consider to subscribe and turn on your notification bell. Once again, thank you so much, and I hope to see you guys soon. Bye for now.